everyone. Once again, I welcome you all to this class. To recall, in the previous class we have learned the various atoms in order to classify the elements. That is the Dobrenius triads, Newland's law of octaves and the Mendeleev periodic table. So today we'll do another atom, the last atom, that is the modern periodic table. Alright. Modern periodic table. So till now all the classifications were based only on atomic masses, right? Where the elements are arranged in the order of their increasing atomic masses. Now let's go ahead to 1913. 1913, where scientists mostly prove that atomic number is a more fundamental property than atomic masses. He said that atomic number is a more fundamental property than atomic masses. Right. So this was a complete shift from atomic mass to atomic number. What is an atomic number? An atomic number is the number of proton present in the nucleus of an atom. So for now we are going to concentrate on the arrangement of elements based on the atomic number. And this arrangement leads us to another law which is known as the modern periodic law. Modern periodic law. This law states that the properties of the elements are the periodic function of their atomic masses. It states that the properties of the elements are the periodic functions of their atomic number. It means that the physical and chemical properties of the elements which occur at regular interval, periodic function, regular interval, are arranged in the increasing order of their atomic number. Alright, so now let us concentrate more on the periodic table. So this is the modern periodic table. Here we have the number of rows 1, 2, 3, 4, 5, 6, 7. These 7 rows, they are called as periods. And we have the groups, the columns. We have 18 columns, and these columns, they are called as groups. Alright, so now let us see how the atomic number is listed in this table. When you go horizontally, you can see the number goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. These numbers, they look like serial number or roll number, right? So what are these numbers? These numbers are nothing but the atomic number. And this is the major difference between the modern periodic table and the Mendeleev periodic table. Because in Mendeleev periodic table, you arrange the numbers in the order of their increasing atomic masses. But in this table, we arrange the elements in the order of their increasing atomic number. Now let us see at the elements, how the elements are listed down. Here we can see hydrogen. In the first row we have hydrogen and helium. In the second row we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So in the same way, these elements are being listed down in the periodic table. And when you observe that the atomic number of these elements get increased by 1, we can see from 1 to 2, 3 to 4, 5, 6. So these number get increased by 1. What does it mean by that? It means that the number of proton of these elements is increased by 1. Alright. And what about the number of their electrons? Similarly, the number of electrons also in every element it get increased by 1, because atom is neutral and it has equal number of protons and neutrons. Alright, now let's see the significance of elements in the periods. Significance of periods. Alright, so in order to understand the significance of periods, have a look at this table. We know in this table we have 7 periods, right? We have 7 periods. What does these periods number tell us? It actually tells us the number of electron shells or electron orbits, which means to say that we can easily predict the number of shells of element present in the period without even drawing the electronic structure. For an example, hydrogen is in period 1, it will have 1 shell. Alright, lithium, beryllium, all these they are in period 2, so they will have 2 shells. And then let's see, sodium is in period 3, it will have 3 shells, and so on. So in order to understand this clearly, let me draw the electronic structure. Alright, first let us take hydrogen, which is in period 1. Hydrogen has only 1 electron, so it has 1 proton, this is in the nucleus. Only 1 electron, then this will be the electron of hydrogen, right? And then now let's take oxygen, which is in period 2. The atomic number of oxygen is 8. So it will have 8 proton. So in the first shell it will fit only 2 electrons. And then now in the second shell will have 6. 6. So 6 with this 2 will have 8 number of electrons. Here it is only 1, here 2, 6. And then now let's take aluminium. Aluminium atomic number is 13. So if we draw the atomic structure, in the first shell will have 2 electrons, in the second shell will have 8, because it will fit, because second shell will fit only for 8 electrons, and in the third shell we are left with 3 electrons. Now you can see clearly from here, hydrogen is in period 1, then it have only 1 shell, alright, this is in period 1, so it will have 1 shell. And then oxygen is in period 2, so it has 2 shells. This is in period 2, so it has 2 shells. And aluminium is in period 3, so it has 3 shells. This is in period 3, it has 3 shells. Like this, you can predict the number of shells of the elements present in every groups. Now let us see the significance of elements in the group. So this likewise you can predict the number of shells of the elements present in every period. Now let us see the significance of elements in a group. So we already know that the elements in the modern periodic table are arranged in the order of their increasing atomic mass, and the elements having similar properties are grouped together. So now let's try to understand this when looking at the table. Alright, have a look at this table. Now let us concentrate on group 1. Except hydrogen, all these elements present in group 1 are metals, and they are called as alkali metals. They all have similar chemical properties, and they all have the same valency, that is 1. If you go to group 2, these elements in group 2 are also metals, and they are called as alkaline earth metals, and they have valency 2. Now for example, you go to group 17. In group 17, these elements here are non-metals. They will have similar properties, and then they have valency 1. So now let us try to understand this by taking some examples. Now let us try to understand the significance of the groups by taking some of the example of elements in the group 1. The first element is hydrogen, and we'll write the electronic configuration of hydrogen. Since it has only one electron, it will be 1. And then the next one is lithium. Lithium has 3 electrons, it will be 2, 1. Next we'll have sodium. Sodium is 11 in atomic number, so we'll have 2, 8, 11, 1. Right? And then last we'll have potassium. Potassium has 19 atomic number, so it will be 2, 8, 8, 1. So when you observe at all the electronic configurations of these elements, what do you see in common? We can see that these are the common one. Right? This one is represent the one electron which present in the outermost shell. Alright? It present in the outermost shell. So it means that all these elements here, they have the same properties. They are all metals. They are called as alkali metals, and then they have the same valency, that is 1. Right? Now if you want to understand some more, go to group 2. If in group 2 we have beryllium. Beryllium has atomic number 4, so we'll get 2, 2. And then we'll have magnesium, which is 12, 2, 8, 2. And then we'll have calcium, which is 20, 2, 8, 8, 2. So similarly here you can see that we can see that 2 represent the electrons in the outermost shell, and these elements belong to group 2. So in the same way, you can always predict the element in every groups about their number of valency or the number of the valence electron. Alright, now have a look again at this table. When you look in this table is being colored with different types of colors, right? So what does this color mean? Actually, it represents for the different types of elements like metals, non-metals, metalloids, and even the noble gases. So in this case, the group 1 represent the metals called the alkali metals. Group 2 represent another type of metals called the alkaline earth metals. Group 13 to 17 include of metalloids and non-metals, and group 18 is called as the inert gas or noble gases. In this group, all the shells are completely filled. So again, if you concentrate on the period 6 and period 7, when you look in period 6, there is one element here with atomic number from 57 to 71, and in period 7, atomic number from 89 to 103. So the elements lying in this column is being put outside the periodic table. This is the one from 57 to 71, and the elements of this column here is put in this another and below the table. from 89 to 103. The element of this one, they are called as, this block here, it is called as lanthanide series because it starts with the element La, that is the lanthanum. So these elements are called as rare earth metals. And then the elements here, all these elements, they are called as actinide series because it starts with the first element Ac, that is actinium. And all these elements are called as radioactive metals. Alright, the elements in this block here, they are called as rare earth elements, and the elements in this block, they are called as radioactive elements. So these are called as lanthanide series because it starts with the first element La, that is lanthanum, and these are called as actinide series because it starts with the first element Ac, which is called as actinium. So all these are about the classification of the elements, and very important thing that you need to know here is that by using atomic number in this modern periodic table, it helps to cover all the anomalies which were in Mendeleev periodic table, like the position of hydrogen, position of isotopes. All those are being put in the right position. So this is the end of the chapter. I believe you have understood everything about what we have done in the chapter, and I encourage you to study some more from the books. So study hard, stay safe, take care.